Well, welcome everybody to CODA's latest webinar, and I'm very much looking forward to this one. We're hearing today from Michael O'Neill from Decom Engineering, who's going to talk to us about their new tools and their new technology that they've got, where it's being used, and some of the problems that it's solving. So yeah, as I say, very much looking forward to this. By a quick introduction, my name is Francis Norman, CEO, Managing Director here at CODA, and as I say, very much looking forward to this. If you have any questions, and I really hope that you do, not that Michael won't do a great job of explaining all about the technology, but there's always that weird little question that gets in your head. If you've got any questions as we're going through, if you want to put them into the chat or the Q&A facility on Teams, then we will come back to the questions once Michael's finished, and we'll get the chance to go through as many of those as we can, while also trying to keep within a sensible time limit for the webinar. So on that, Michael, I'll hand over to you to take it from here, please.
Fantastic. Yeah, thanks very much, Francis. Great to be here. Thanks for having us on. And yeah, we're really looking forward to running through this with everyone today. Okay, well, just a quick introduction from myself then. So my name is Michael O'Neill. I'm the Head of Business Development for Decom Engineering. I have been covering the Australia region for the last about 18 months now, and my focus has been on delivering new products to the market, establishing Decom's footing there, and then looking at the wider global markets and see where we can sort of expand and grow to. So just for anyone that doesn't know who we are, so Decom Engineering is a company founded in 2011. We built the business around one key focus, and that was bringing subsea chop saws to the market. We knew that chop saws were already something that was existing in the market, but no one was doing them with the sort of full focus and attention that they deserve for the value that they can bring to the space. So Decom set off to start working on R&D, developing new tools, and working on developing the first chop saws that we brought to the market, our C112 and C124 chop saws. In a little bit of a, to be clear with the naming of our tools, so this applies across the board, is we typically name our tools what they are. So it's C1 is the chop saw range, and then Tract is the cut and recovery system that we'll be covering today. And then the numbers at the end of that tell you the maximum size that that tool can cut and recover. So for this, we started with the C112 and C124 chop saws, so they will cut up to 12 or up to 24 inches in OD. And the Tract system for today will cut and lift up to 16 tons and 16 inches in OD. So we built these and brought these to the market on the thought process of it being a faster and more reliable cutting solution for the subsea market. It was a massive success. We were seeing results 3 times faster than diamond wire saws and 5 times more cuts before we needed to come up and change out blades. We never failed a cut on anything that we've gone to cut subsea, and that includes thick plastic coatings, duplexes, chains, any range of products that fits within the parameters and the sizes of our tools. We've been able to successfully cut. So that has really pushed Decom forward to expand and build new tools and look at the market and address new challenges, which is why we have such a broad range of tools that you can see on the screen there. Where we sort of landed on this was there was a clear hole in the space, or a clear sort of time sponge that was kind of made itself clear in the change out to go and do the recovery work when we're doing the cutting. You spend all that time getting tools down to depth and going and doing the cutting only to go back and then recover it later with separate tools and separate solutions, and doubling up on vessel time, doubling up on crane capacity. So we looked at how we can adapt something that can do both. So we can do it simultaneously without having to have simultaneous operations running with multiple tethers in the water or different cranes having to be used. So the gap in the market itself we found was for the cut and lifting being planned as separate ops. There was a lot of downtime between actually going to do the recovery. There's downtime when you come back to the deck. You have to re-rig all the tools and change these out properly, all your new checks before you dive again. And all this extra handling is just going to cost you more on vessel time. It's more movement, and then sequentially it's going to be more cost to the vessel operator and inevitably to the operator. So this solution was designed to really speed up this process and make it as efficient as possible. So by doing this, we've also shortened that cycle time. We've been able to minimize all this handling time on deck. There's one system there that can do everything, all from one powering point on the tool. And it just makes everything simpler. You can mobilize one spread of tooling. You don't need to work with multiple vendors and cross hire in different cutting and recovery tools. You can make this really predictable and really repeatable. And for us, this tool has just been a massive success, from being something that was completely conceptual through to working with an Australian client and actually delivering this offshore on a project. So let's go into a little bit of detail around the results. So this is the really critical part for us that says, yeah, this was money and time well spent from us and from our customers. So with the chop saw tool, so this tool is in two sections. You have a beam that will do the recovery and a chop saw mounted to the end of the tool. So Decom Engineering's chop saws are patented, and they are the only lead screw driven chop saws in the world, which basically means that rather than them being ran driven forward, they're on a screw system. So we can continuously feed that blade through nice and slowly, nice and consistently, and we are getting the sort of benefit of the control. And that slower feed makes us faster on the cut. We don't stall, we don't stop, we can consistently work our way through, and we maximize our blade's lifespan as well. Our tooling is all designed around its low RPM and high torque. So our blades only rotate at around 40 to 45 RPM. And it's a milling system on the end of our tips. So when our blades rotate, they don't go fast, but every tip is working. Every tip is peeling its way through the material. It's not abrasive and taking off sort of powders. It peels like a lathe, and it actually takes off sort of milled kind of spirals of material, which sink to the seabed. So all of our tools adapt that same kind of method. And with the grabs, we thought this was so important to make it as flexible and sort of dynamic as possible. So rather than having a solution that is just one encompassed set beam with a tool bolted to the end and that's it, it's one configuration, we've done this completely modular. So we have a beam that can be changed in length, so we can add sections in, we can take sections out, we can move the grab positions on that beam itself, and we've got the saw mounted to the end. We can scale up the size of that saw, we can scale down the size of that saw, and we can also split the tools. So when you rent this equipment, you're not just renting one combined unit, you can then also have two tools that you can use independently if you need to as well. So it just gives you that full comfort offshore that you have something that is capable of doing all of this cutting without the need to do rent in multiple products and then spend the time actually coordinating all of that. So a little bit of the results of what we're seeing is we're seeing cut times as fast as 3 minutes. So this is ranging, at the moment we're cutting flexibles. So these range from 4-inch to 8-inch flexes that we're doing at the moment. So we're seeing as fast as 3 minutes with an average of around about 4.5 minutes to do this cuts. We have a deck-to-deck estimate that we're looking at of around about 30 minutes per cycle. So that's 30 minutes so from lifting on the deck to getting to the cut position, connecting with the ROV, completing the cut, and then recovering that section to the deck and releasing it into the basket or wherever we have as the arrangement on the deck. For the actual project that we're on at the moment, the operation is slightly different. So we're seeing cycle times as fast as 9 minutes on the ongoing scope, because we're not recovering to deck, because we're down at about 800 meters water depth. So to make this as efficient as possible, we're deploying, gripping, cutting, and moving to a subsea basket, filling the basket and recovering that to deck. So now across over almost 800 cuts completed to date on that scope, and we're seeing over 40 cuts per or so up to 40 cuts per blade. And when weather allows, we could see about 450 meters per day being recovered. So it's around about 40 joints for the basket in 12-meter sections. Again, this scales depending on the recovery length that we're looking to go for. So this is a beam set to do 12-meter joints. You could lift much larger, sort of 24-meter joints if that was the preferred, which obviously will see an increase in the recovery rate per day. So just so this is very clear to everyone, this will be available to send to anyone as and when they like. We've built an animation that really runs through how flexible this tool is. So this is our track 16. So tracks means twin recovery and cutting system, and 16 just means that we can cut and lift up to 16 inches in OD. So you can see there, capacity up to 16 inches. We can scale this up as high as 30 inches at the moment. We are looking at potentially larger, but at the moment 30 inches is kind of where we'll stay. We can scale up or down the grab sizes, and we can adjust and move where these are positioned on the beam as well. So we can grip this depending on however much access is on the project. The project we're on at the moment has this set up with ROV and hot stabs. The tool can also just as easily be run with a downline. It's just dependent on water depth and what the preference is. For an operational sort of perspective, the stopper on the end there is what we use as a length verification method. So we know if that's on the end, that distance from there to the blade is set. So we have about 12 meters from end to end on this, so we know that when we're cutting we can fit this in the basket, and we're not doing shorter cuts, we're not doing longer cuts. It's really consistent, easy for us to track and manage. The blade itself just feeds its way through there. We can then drop that to the seabed while keeping control of the cut section, and then we can, this animation shows us the recovering to deck, pull this back up to deck where it can be stored on the vessel or in a basket ready to be offloaded at the beach. For the blade changing itself, so like say about 40 cuts to a blade, and we've built this hinge system so that on deck you can just open and close this, and a quick 4-bolt arrangement to swap in and out of blade. So we can do this really quickly in around about 5 minutes. So let's look at the actual project that we found. So the important thing for us at Decom is we're constantly looking to find innovative ways to adapt and build chop saws and bring them to the market. But we are only a small company. Decom itself is only 12 people and staff at the moment, but we operate globally. You know, we have operations ongoing in North and South America, Australia, the North Sea, Norway, and we have multiple projects that are very close to moving through in APAC and Middle East as well. So we develop tools by working with the market and actually working with our customers. We've done this in the past with Deep Ocean and Shell and All Season Shell, bringing our 32-inch and 46-inch chop saws to the market for specific challenges. And for this one here, we did this working for a project in Australia, off Western Australia, the Stybarrow field. There's 15 kilometers of flexible flow line, various ODs, like say from 4-inch to 8-inch that need to be recovered. For us, we see this as a massive opportunity, a £1.5 million campaign, which is the largest opportunity that Decom has had to date. But we know that this value is there because we've saved significantly more on the vessel time. So that is such a cost benefit to the customer by having this one package that they can utilize. We are looking at about 1,200 cuts to complete in about 120-day window, so allowing a bit of time for weather delays and any kind of downtime that we would have offshore. So the 3 kind of C's that we look at: cost, cycle, and confidence is what we like to base what we do on. So we like to make sure that there's a cost advantage. So for this project, we've reduced the amount of vessel days that were going to be required. We did a similar campaign at the start of last year, and using just our standard 24s and then recovering separately in the same period of time that we've been offshore now. So right now we've done about 800 cuts. In that same window at the start of last year, using just the cut and recovery independent methods, we only did about 150 to 200 cuts across that whole campaign. So we've directly seen the impact that this has had and how much more efficient it's made this. For cycle, we have seen that we've maximized how much we're getting out of this. We can deploy it at the start of the shift. We can be down there. We can do the 40 cuts, all these movements into the basket, so that we're not having to spend all this time just waiting for cranes to pull the tool up and drop it back down. So when we're down, we're working, we are getting that to do as many cuts as possible, and then we just recover as and when we have to. And then for confidence, it's hard to argue with this. We've had 0 downtime due to the tool at all in the project. So because of this tool being on there, at no point has this gone down or had any issue that's actually prevented us from deploying or caused any delays to the scope itself, which is a huge testament to how efficient and reliable this tool is. It's always good to see some action shots and get a better idea of what this looks like actually in reality. So on the left-hand side on those images there, we've got one of the basket recoveries that you can see with all those sections kind of stacked up. We've got the tool sitting on the back deck, just on the grabs that we've got there. We do also have a landing frame with it. This tool sits on the deck as well. which we pull off of just for pre-deployment, just to get everything checked before it goes in the water. Moving in the center, we did some additional testing. So this is showing concrete cutting on a sort of thick coated pipeline. And then on the bottom right, you can also see that piggybacked and bundled with umbilicals and other lines attached to there as well, with spacers attached. So we've done this as trialing for other projects to show that this tool is also suitable for not just single cut, but multiple bundled sections put together. We can grip it all, pick it all up, cut straight through and take it all away. And we take away the risk for any floataways or plastic waste or anything to get away and escape the grabs. It's one single deployment, grab, recover, and you don't need to worry about the excess that's there. It's all clean. And then at the top, you can see a basket full of cut sections just being offloaded to the shore as well, which is great to see. There's a video here as well. So we've seen the animation. That gives you a very good idea of the perfect reality of what goes on in an operational cycle. It's really important to see these kind of in-field videos and see what's actually coming from the ROV and what our guys are watching here. So you can see this is one of the flexibles picked up with the tracks. The tool has actually gone on, gripped it in the seabed, picked it up out of the seabed, and then the blade starts to feed through. The big benefit of this for us is when we pick it up, the flexible wants to bend away. So when we have that picked up, it pulls that material apart so the blade can feed through, and it constantly wants to open up and widen that cut. Because as a lot of people on this call will be aware of, with chop saws, the biggest consideration that you have is when you're doing this cutting, if you're in compression, that force coming down on the blade wants to nip it, it wants to stall it, and it wants to slow everything down. So by doing this, we take that factor out completely. We're just making sure that this constantly wants to open up, and we're in full control here. So your blade is rotating. You can see it's nice and slow. It doesn't stop, it doesn't stall, it doesn't bind up in there at all. There's nothing squeezing that blade, and it just slowly works its way through, millimeter by millimeter. And then once we actually get to the back half of the cut, we're just going through the plastics and things can speed up a little bit, and eventually we'll get to the end here, and it will just do a nice clean cut. I think it's also good to see a lot of people look at this and think shearing is obviously the way to go. We like to do this with the chop saw because now we can be competitive with our shears in overall cycle time. To be honest, once we've demobilized from this project, we're confident that we'll have enough evidence there to say that we are actually faster than that as a solution, rather than shearing everything, then going back and picking it up. By doing this all in one, yes, you sacrifice a little bit on your cut time, but the efficiency of having it all in one solution is far greater than going and then having to send the vessel back and do all this pickup work and get back down there. So yeah, that's the cut complete. Blade stops, and then we can release this section that we're not recovering back to the seabed. And then you've got this clean cut on here. So that means when we recover this, the water can drain out. We're not taking that back on shore, and you have the benefit of having clean cut ends to take back on shore that lets you recycle it easier. Let the onshore teams get in and do all the testing that they need to do. There's no double handling and recutting on shore. It's done right first time. And I think it's a great thing to see with this. I'm not going to read this out in detail, but this is a statement from the current project that we are on, and I think it speaks much more. It's much more value in seeing something like this come through compared to me just telling you this is what we do. This is a testimonial actually from the vessel that says this is what we've been up to, this is the performance, this is the impression that the team has made. And what I really like about this as well is Decom being a small team, and the way we like to do things is we're not some massive corporate entity that's going to go in and take over the world. That's not the goal for us. We want to do what we do and do it right. And I love that this testimonial here is very clear on it's the people. It's not just the tooling. The tooling is obviously great, but the people and the attitude and the reputation that they have on deck for getting involved, doing everything as they should, safely, quickly, really engaged. That is the messaging that we like for Decom. That's what we do, and that's what we pride ourselves in doing. And for us, we're always looking to constantly grow and improve the team. We're recruiting for a lot of people at the moment, so we're at this great growth period where we've got loads of talented people looking to join the team and help us with the constant kind of innovation that we're looking for. And then just a final slide from me here is what's next. This is always what we like to do at Decom is we don't like to go, this was a great success. Cool, we'll just run with this for the next 3 or 4 years. We're always looking for the next innovation. What do we do? How do we improve? How do we refine this? And even from the project that we're on just now, it's the first scope of the track system. We've already improved the design. We've applied lessons learned. We've taken the comments of our clients on board, and we will build this and keep constantly working on this to make it more efficient, more cost efficient for the customers, make this the go-to solution for large-scale pipeline and recovery campaigns. And we do really believe that that is something that is what we're capable of achieving. And the tooling itself is going to be a big shift in the market for cutting and recovery. And it hopefully will make a lot of people in this call's lives a lot simpler. It's nice and easy to plan. It's one clean spread. And we just see a lot of benefit in this. So kind of final points from me on this is we are always adapting. We are already, because of this first project, we have multiple ongoing bids, which are very close to award, which will see us build more of these tools. We have one in Australia at the moment. By the end of this year, if all goes to plan, we will probably have 5 of these in circulation, mostly stationed around the world, with Brazil, the US, and Asia being Middle East being focus markets for us with this tool, as well as Australia. The unit that is currently in Oz will remain in Oz. We don't like to pull everything back to the UK and do everything there. We have partnerships within region that will store and help us mobilize the equipment, so that can stay down there. We can arrange for people to come and see it, come and watch demonstrations of the tooling, and actually put your hands on it. And we are avoiding this constant of ship it from the UK and adding up logistics and things. So we're trying to be as dynamic as possible. And the good thing is this is also going to let us bring the new sizes to the market. We're already at the late design stage of our Tracks 24 and Tracks 30 for larger pipeline recovery scopes. And yeah, if all goes to plan, we're going to have a fantastically busy couple of years and really make a difference in the cutting market with this tool. And yeah, just finally, for me, we are going to be traveling quite a lot over the next few months. So myself and my business development manager, Sam, who is now going to be taking more of a lead in the Eastern Hemisphere. I'll be over at Tieback in Houston. We'll be in Australia for EXA and then DNA in Perth, as well as Rio Oil and Gas. We'll be up for, there's quite a lot of conferences this year, but we'll be traveling, and we're in region at least once per quarter in every region. So if there is anything that you want to arrange and have a discussion around, we can set that up. And yeah, Francis, I can hand back to you there. That is a very quick deep dive into the world of tracks.
That was great. Thank you. Thank you very much for taking us on that journey through there, Michael. I have a quick question for you myself, and then we've had a couple of questions that have come into the chat as well. So just as a reminder for anybody that has questions, if you haven't had the chance yet to load them up, please stick them in the chat box, and we'll get to them. Mine is more of so you mentioned at the end of your presentation there, Michael, that you've got the machine now down here in Oz. My recollection is that you also have a couple of your other more traditional machines scattered around the world as well. Can you just give me a quick reminder of, just ballpark, what you've got where, just in case someone's thinking, man, I could do with one of these things tomorrow, so they know where to go for it?
Yeah, absolutely. So for Australia, obviously we have the track system down there. We also have 2 of our C124 chop saws, with probably a third going to be heading down there in the next couple of months. We also have one of our C116, which is our lightweight sort of chain and riser disconnect tools that we have, that just floats in and does the cutting work, single side kind of clamping tool. We have one of those that's going to be coming down to Australia for a project very soon as well. Our C116s is the biggest additions to the fleet in the last 12 months. So we went from only releasing that last year to now we're building units 6 and 7. So we have 2 in Brazil at the moment, 1 in the US. We have 2 that are in Aberdeen at the moment, 1 just being finished, and then obviously 1 that's going to come down to Australia. And then for the Middle East, we are in the process of packaging 1 saw that will go over there just now. It's looking like it's going to be our C112, so smaller kind of chop saw. that'll move over there in the next week to 2 weeks maximum. We'll get that moved over there because we're trying to get in a position where we have all this work globally. You know, we're working pretty actively in the 6 regions that we look at. So we don't want to have this constant, oh, well, it's going to sit on transit rate for the next 3 weeks to get it out there. And it's just this bad way of working. We want to be there so that we're in country, we can be reactive, we can be flexible, and we've got the tools there ready to mobilize and show that we're not just dabbling and taking whatever work we can, whatever we can get. We're actually committing to those markets.
Yeah. Oh, that's great. Thank you. Okay, so to the questions, we've had a couple of questions, as I say. First one came in sort of quarter of an hour into your presentation. Then that was from Stephen, and it was, have you looked at recovering 2 sections at a time instead of single sections? So
yeah. So at the moment, it wasn't something that we really needed for this campaign. So it was actually an afterthought, to be honest. Like I say, we were doing and building this to what we saw as making sense for the project. It was actually something that we had a conversation with the client about afterwards. It was like, oh, and we've presented around this tool quite a lot recently, and it's actually quite a frequent question that we've been asked is, you can pick up one, why don't you just pick up more? You know, these tows lock really well. It's a really good recovery method. So yes, we can. We've looked at, we can recover. At the moment, we know we can confidently recover 3 sections. It's all just about making sure that it fits within the actual grab capacity that we've got there. But like we said, with the tool being modular, we can make those grabs larger. So even if you don't scale up the saw, you can increase your grab capacity so you can lift more weight, lift more diameter.
Cool, excellent. Okay, so that was that one. The next one and the one after that actually feed it a little bit into each other, but I'll start with the first of the 2 that we've had. And that was, how does the solution work for semi-submerged pipelines? So I guess as you get closer to the beach, you've got pipelines that are heading towards shore crossings and what have you. How would it work for that?
Yeah, I mean, no real change for us. I mean, if anything, it's more efficient. You know, we can just run that. We don't even need reels and lines. You know, we can just have that with a deck hose connection running to the tool. We can the positioning, the cutting, the sequence is still the same. We wouldn't see any real change to what we're doing other than it just being much faster to overboard, grab, cut, and recover. It's just a faster operation. We're actually looking at a pipeline at the moment, which is 3 actual pipeline sections, kind of case. It's almost like an uncased bundle section. So you've got those 3 different strands within there with the bulkhead arrangements. That's in relatively shallow water, you know, only 20 meters of water or so. So we're looking at that kind of operations just now as well. So yeah, we would expect that to perform exactly as we would see for the flow line recovery stuff that we're doing now.
Yep. And then we're getting even drier for the next question. And that, oh, hang on, we've had another one come in, which has shifted them all on my screen. Do you have any experience with the cutting of conductors above water with your chop saws? And if so, more or less, what's the cutting time?
Yeah, so as long, assuming I'm understanding this correctly, yeah. So we've got our C132 chop saw, which is something that we built with Allseas and Shell for the Brent Charlie conductor removal campaign. So they were looking for ways of saving time, and what they came to us with was, we know that diamond wires can go through these things. We know that chop saws could definitely go through these things. How can we take away the effect of the pinching and the multi-string, and how do we actually get that in? And also, how do we combat that it's a large cut with no crane access? So our C132 was built to have a large sort of robot, similar to our older designs, the kind of chunkier design chop saws, but we took that down to 50 kilograms of water. We integrated buoyancy into there. So we made this nice contained kind of package that can be flown with the ROV and actually go in and do these conductors. So for actual performance on those, we were cutting 30-inch casings with, I forget the inner string size, but we were doing multi-string 30-inch OD conductors in about 45 minutes. The biggest advantage that we had was we built this anti-pinch system into the tool. So where the pipe rests into on the tool, there's an extension bracket above and below our clamps, which when you pull in on the clamps, you bend away the material ever so slightly. So as you're cutting through, it takes that pressure off us on the external casing. And then when you pin that internal section, that just cuts nice and cleanly through. So it's a much faster option now. The only challenge we do have with conductors is the chop saw is obviously a larger tool in general, so there is access restrictions, but where we can get in, we're a fantastic method for that.
Very good, thank you. So we've had another one, as I say, we've had another couple of questions come in. So what's the minimum seabed required? And part of the same question, can the tool operate on half and fully buried pipe? And then keeping going on there, what happens if the pipe is laying on hard coral or rock? Can the grab overcome hard clay seabed? So there's a lot in that one. If you can see that question at your end, yeah.
Yes, so for us, the purpose of this tool was to try and minimize dredging. You know, there's a lot of weight behind this tool. The toes and everything are designed to be sort of very streamlined so that we can go into the seabed and pick up. So anything that is less than 50% buried, we would be able to actually go in and pick this up and just lift it off the seabed without any need for dredging. As long as we can visually see that pipe is there, know exactly where we need to be, we can get in through softer seabeds, silt and lights, and pick that up, and it's no issue, no need for dredging. For the harder materials, we haven't done any sort of detailed studies at the moment on what we actually need for access on those. I would imagine for things like clays, is if it was sitting on top of the clay and we just needed to pick it up from sort of being partially in there, say 25% sort of resting in there, we would be okay to pick that up. But things like coral and harder rocks and these kind of things, I don't actually know. It's something that I can run past our technical team and get a better idea of how they can either minimize the impact of that and guarantee that we can clamp close, or just what the scenario would look like for us and what we would do to make sure that we can pick that up. But yeah, it's because the tool's sort of in its infancy, we're only kind of operating in the one seabed sort of condition at the moment.
Yep. Interesting questions, though. Gives you sort of shows all sorts of options, doesn't it, for where you're going with it?
I'll have to just say, I'll just pick everything up. It's fine, but yeah, you've got to be sure.
Next one, more of an ROV type question. So here, curious to know a little more about the ROV operation. When a cylinder is extended, additional oil volume is required to account for the rod displacement on the return side. Over time, this creates a net oil consumption within the system. With this in mind, how is this managed operationally, and how frequently does the ROV need to recover to the surface to replenish hydraulic oil?
Just a bad time to say I'm not an engineer, and this is just I'm the salesman. I mean, I can answer that to a degree. So,
yep.
Obviously, my understanding here is, so when we're doing this, we're either running it from a downline and it's all just running from the HV on the top side, or we're running it from the ROV with a dirty work pack connected to the ROV. I'm no ROV expert. I've never heard our team mention anything to do with actually having to come back up and do this sort of restock of oil or replenishment of oil for the ROV itself. I know it's not something that we've had to do for our tool specifically, and they don't have to pull it back up to do that because the ROV is low on oil. What the actual volume of oil that we need for the tool is low. It's not a lot of oil for the actual system itself, and because we have this lead screw drive system, yeah, there's the cylinders on the side of the clamps and things. The three systems that are in there, we only actually need about 60 litres a minute to function and operate this tool. So it's 60 litres a minute from a work class ROV is absolutely fine at around about 200 or 210 bar pressure. And yeah, it's all from what we've seen by working with ROV teams, and this applies across the board to all of our tools. They're all relatively similar requirements for flow and pressure. Is that any work class ROV that we've worked with has had the capacity to run the tools, and it's been no issue to integrate with on deck.
Very good. For a non-engineer, I think you did a pretty good job of answering that one. And I would say to all of the folks that have put questions in, if you want a bit of an expanded answer on that, then drop Michael an email. He will find someone from his technical side who can fill in the gaps and come back to you with answers on all of that as well. So look, at the moment, yeah, go on, Michael.
we have our engineers in these regions as well. So it's not just the business development team that go out and meet with the customers. We quite regularly fly our engineering team with us as well. So if there is any kind of technical needs, let us know where you are and we can actually physically come and see you.
Yeah, or similarly, if you happen to be based in any of the many locations that Michael said their team are going to be at in the next few weeks, then go and get a coffee and have a chat with them about the technical requirements and operational envelopes for these machines. So at the moment, barring anyone throwing in, oh, there we go, a last minute question, and there it is. I was going to say that's us, but we got one in. Well done, Maya. Do you have scheduled maintenance periods during ops? And if so, how long are these?
Yes, so every time the tool dives, obviously we do pre-dive checks and we make sure everything's functional. The tool itself, as much as it's a great tool and it looks like it's all singing, all dancing, it does all these things, at its core, it's straightforward. There's not a massive amount to the tool. Every time that we deploy and then recover, the team will give that tool a workaround and actually go into detail. And we built this to be really, really straightforward to work on. They can access everything really easily. So as soon as this comes on deck, every time the guys will do a walk around and they will actually do a little bit of basic servicing and make sure that everything is 100% before we redeploy, which only takes them about 30 minutes to go and do. So for this, and this is high volume cutting, this isn't just going and doing a cut or two and then coming back up. We're doing 30, 40 cuts at a time here. So it's pretty consistent active cutting. And yeah, about 30 minutes on deck when it comes back on, which, well, the crane is being utilized for other things on deck. That gets us ready to redeploy. Anything that does need to be fixed or changed on there, like if there's a seal that needs to be replaced or anything like this, the guys can go in and they can do that typically within an hour, a couple hours maximum to go and get that done, and they'll normally work that into any kind of downtime that we've got for weather.
Right, very good. Now that's actually triggered another question from me on this one. So this particular, the machine that you built now, the one that's out there, when you were going through the presentation, you said it's about 5 minutes to change the blade. Yeah. Are these blades the ones where you have interchangeable teeth on the blade, or is this one where the blade itself is sort of one big solid piece of metal?
Yes, so this tool in particular has the solid blades, just at the 16-inch size. So what the technology we use for our blades isn't so much dependent on the tool we're using it in, it's dependent on the size of the blade. So for the 16-inch blades, it's not commercially or time effective to do the replaceable tips because each tip needs to be changed out manually and your waste product isn't as much as you would see in the larger tools. If we were doing the Trax 30 with a much larger core and more tips, it's more cost effective and more time effective to actually go and change these tips out. So you can do a full tip change out in 2 hours or so. Or a 50% change in an hour, just to get things ready to redeploy. So it's just dependent on the size of the blades. It's more of a safety factor than anything, to be honest. It's not a safety issue changing these smaller blades because they're not heavy. If you were to try and argue to change one of these 200 kilo blades, it's not anyone's preference to do on deck where they can avoid it or not regularly, and it also ties up the crane, whereas this is all just handheld work.
Yep, makes sense. No, that's good, thank you. As I say, that was more of a curiosity from my side than a question that had come through. So look, I think we've had some great questions come through from everybody. Thank you, Michael, so much for that presentation. You included your contact details at the end of your slide bit. We'll make sure that your contact details are all over the recorded version of this when it goes up on YouTube in a few days' time. Says he, looking at his colleague across the table who does all the magic in the back end to load these up. If you want to share this with your friends, if you want to share it with your colleagues, if you want to show it to your family when you get home on an evening, it'll be up on our YouTube channel in a few days' time. Michael, look forward to seeing you down here in Perth in a couple of weeks for EXA. And look, thank you everybody for joining us, and have a great rest of your day. Thank you.
Thanks, Francis, and thanks everyone for joining.